Hello, I'm Benedict. I'm a co-founder of Foursquare Tutoring, and this is problem 17 from the 2023 AMC 12A. It starts off with a frog named Flora, who starts on 0 on a number line, and this number line extends indefinitely towards positive infinity. And we're given that Flora leaps a positive integer distance m with probability 1 over 2 to the m. And what's the chance that she will eventually land at 10? So 10 seems like a pretty arbitrary number right now because this goes off infinitely. I'm going to look at what happens if she lands at n. Just some random point n. What is the probability of this happening? Because maybe we might get an expression in terms of n, plug in n equals 10, and then we're good to go. So the first most obvious case to me is she just goes in a bunch of hops. She goes from 0 to 1, 1 to 2, 2 to 3, and then eventually she'll end at n. So since she's going from 0 to n, there will be n gaps for her to go through. So that means each of these will happen with 1/2. We'll have probability 1/2 because the distance is just 1. 1/2, and this is 1 over 2 to the n because we have n gaps and she's doing each of them. What happens if she just does the opposite of that, right? She could just go straight from 0 to n. And in order to go from 0 to n, the probability of that happening is 1 over 2 to the n because the distance is n. So what exactly are these cases? So this case is if she's skipping everything. So skips everything. And this is if she skips nothing. So what if she skips one number, right? Let's say she will skip 1. That means she'll go from 0 to 2, 2 to 3, 3 to 4, and then so forth to n. So this first jump, 0 to 2, 0 to 2 occurs with probability 1 over 2 squared. And then the rest of them, we're going to have a bunch of 1/2s, and then this is going to come out to something. But what will it exactly evaluate to? So we're going to have, we had n before. We had n total jumps. This time we're going to have n minus 1 total jumps. Because when we skip this one, that just gets rid of a potential jump. But how many of those are going to be 1/2? Well, it's going to be n minus 2. Because one of them is 1 over 2 squared. So we're going to have n minus 2 1/2s. This gives us 1 over 2 squared times 1 over 2 to the n minus 2. Which is, again, 1 over 2 to the n. That's very interesting. It seems like everything's going to be 1 over 2 to the n. But we're not done yet. Because this is just what happens when she skips 1. In fact, she could actually skip any number from 1. You could do 1, 2, 3, 4, all the way up through n minus 1. She only has to hit 0 and n at some point. So she can skip any n minus 1 numbers. And they're n minus 1, 2. Or she could skip any one number from the total of n minus 1 to choose from. So the probability of this happening is, we have the probability of one case, we have n minus 1 total, and we want to choose 1 from the n minus 1. So what if she skips 2? Well, if she skips 2, we want to be able to choose 2 to skip. She could go 1, 2, 3, skips that one, bam, bam. But this will fall under the same sort of logic umbrella that we established. Because if she skips 2, then she's going to have one less jump than before. But that one less jump than before is then made up with this extra exponent we introduced because she has to jump more distance. So when we introduce this bigger term on the bottom, in a way that sort of cancels out with the jump that we don't do. So she's only going to be doing n minus 2 total jumps but we're going to have a 1 over 2 cubed or 2 1 over 2 squareds or whatever. So the probability of one specific case will also be 1 over 2 to the n. Now, if you want, you could actually just prove this at home. Just bring out some like 2 to the k's, 1 over 2 to the k's, write out something for an arbitrary skipping of a position. But this is just sort of the underlying logic of this happening. So we have a probability of 1 over 2 to the n, but this time we want to skip 2. We want to choose 2 from the n minus 1 to skip. So this is the probability of skipping 2. And now I think we're beginning to see a pattern because we have skipping nothing. This is really 1 over 2 to the n times n minus 1 choose 0. And skipping everything, this is the same as 1 over 2 to the n, but we're choosing all n minus 1. So what's the total probability? We can skip anything from 1, 2, 3, 4, all the way up to n minus 1. So the total probability of this happening is 1 over 2 to the n times n minus 1 choose 0 plus 1 over 2 to the n times n minus 1 choose 1 all the way up through plus 1 over 2 to the n times n minus 1 choose n minus 1. And from every term we can factor out a 1 over 2 to the n. And this is n minus 1 choose 0 plus n minus 1 choose 1 all the way through n minus 1 choose n minus 1. And this inner term is equal to the n minus 1th row of Pascal's triangle. So it sums up to 2 to the n. So this is just equal to 2 to the n minus 1. Sorry, I meant 2 to the n minus 1. We can put it over a common denominator here by multiplying out, and then divide everything by 2 to the n minus 1. So this is equal to 1 over 2. So no matter where Flora has to go, the probability of eventually hitting that point will always be 1/2. So for the n equals 10 case, we will still have the probability be 1/2. So the answer is choice E.